Well, hey there, and welcome back to the GameDev Tavern. Make yourself at home, just grab a nice chill drink and come join me as we create fun little games together. My name is Nicholas, and this is episode 16 of the tutorial series where we create a pixel art 2D soccer game from scratch in Godot. And welcome back. Alright, so in today's episode, we are going to finish all of our AI logic. We'll start by giving AI the ability to tackle. Now, let me first hop over into the player script, and inside the player movement, I think we had commented out the ability to tackle, so I'm going to just remove this. And you'll see that when we start the game, while we did have the ability to tackle with the animation and so forth, the tackle actually doesn't do anything yet. So if I try to tackle a person who has the ball, it currently won't do anything. So we need to actually write the logic for this. And the main piece of logic we'll follow is that a player can only be tackled if they have the ball. That's the first thing. Otherwise, it's going to become more of a brawler game than anything. And also, the player will need to be part of the opposing team. So we won't be able to tackle someone within our own team. Okay, so the two pieces of logic are pretty simple. And we'll need to introduce a new state. Whenever a player gets tackled, they'll hop into this hurt state where they'll won't be able to do anything for a little bit of time. So first, we'll need to start by detecting whether the foot of the player that's doing the tackle is actually making contact with whomever has the ball. So let's hop over into the player 2D view here. And in the animation player, I'm going to start by picking the tackle animation to kind of figure out where my area is going to be. So we need to create a new area that will do the detection of whether that tackle is making contact. Let's create, so back onto the player scene, Control A, and I'm going to create an area 2D. And I'm going to call this tackle damage emitter area. Okay, so first let's remove set the monitoring and monitorable to false. We'll actually do that in the code. We'll only want that area to be monitoring whenever the player is actually doing the tackle. And then let's make sure that we are setting the right collision layers. So we don't need to be on any collision layer. We're not going to try to detect this, but we are going to try to detect the player. So whenever that area is making contact with another player, we're going to emit the signal on body entered. And okay, so everything needs a collision shape. So Control A, let's add a collision shape 2D, and let's create a rectangle. I think that should work. And then let's make that maybe 7 by 7. How's that look? And then let's drag it to where the foot is going to be. So in my transform here, I have 13 minus 3. I think this looks okay. And basically, this area here is going to make contact with other players' collision shapes. So this one here, which is a capsule. Okay, so we are going to need to access this in our code. So as usual, we're going to hop over. Let's click on the tackle damage emitter area, right click, access as unique name, and we're going to create an unready variable. The first thing we'll do is whenever the player is facing right, we'll want that area to be here. However, when the player is facing left, we'll want to swap the scales X value. So if I hop over here, if you set the value to -1, you'll see that this actually properly maps whether if the player is tackling towards the left-hand side. All right, let me set this back to 1 and hop over into the code. Let's start by creating an unready variable. So tackle, I'll put it here. Damage emitter area. All right, and then let's flip the X position whenever we're facing right or left. I think we can do this inside the let's see, flip sprites. I think this should work here. So tackle damage emitter area, that's scale.x. So here it's going to equal 1 when we're looking towards the right, and it should be equal to -1 when the player is heading towards the left. Okay, so now let's listen to the signal whenever that area is connecting with the body. So again, because we're only looking for other players, we'll know that it must be a player if we are entering this signal. So into the ready function here, okay, and then let's create a method called onTacklePlayer. Okay, it's going to complain because we haven't created it yet. Let's hop over down, and wherever, let's see, I think this should work here. All right, so this takes an argument, which is going to be the physics body. In our case, it's going to be the player. That's the only thing we can collide with, so we can already set that type right here. Doesn't return anything. And so here, let's have our piece of logic. First, let's make sure, because the player calling this code also has a collision shape and also has this area. So let's make sure that we're not trying to tackle ourselves. So if player is different itself, and then we want to make sure it's someone from the other team. And then we'll want to make sure that that player is the person who currently has the ball. Okay, so if no one has the ball, then ball's carrier will be null, which means that this condition here will be false. All right, so if all of the conditions are met, then we'll want to have this body, right, this player, go into some form of hurt state. So for that, let's go ahead and call a new method we're going to create. Let's call this getHurt. And thinking ahead, what argument do we want to pass from the player who's doing the tackling to the player who's getting hurt? I think it might be useful to know kind of the direction from where the damage is coming from. And the reason for that is the player who currently has the ball is going to drop the ball. And ideally, the ball is going to go in the same direction as the player doing the tackling. So maybe we can just keep some form of vector, directional vector, to know where that tackle is coming from. So the tackle is coming from a vector which is our current direction and going towards the player's position. All right, so let's create a method called getHurt. Let me create it here. So this takes one argument, which is the origin of the tackle. And for now, let me just print something. Let's just try this out first. So the last thing we'll need to do is right now, we're not monitoring anything, so we need to set that in the code. Now, the only time we want to be able to monitor whether we're making contact is when we are in the tackling state here. So ideally, within this state, we actually have access to this damage emitter area, or we actually want to turn the monitoring on and off whenever we enter and exit this state. So currently, the states don't know about this dependency. So as usual, we're going to need to inject this dependency into our states. So let's hop over into our player, let's see, what is it, player state. And let's have a new dependency. So we'll call this var tackle damage meter area. We'll set that to null initially. And then let's make it as part of the setup. Instead of putting it at the end, I actually like to keep the AI towards the end. So maybe I'll just add it like one before the end. So context tackle damage emitter area. This is going to be an area 2D. And then I have my context AI. I don't know why, it just feels like all of those are dependencies, part of the player, whereas this is something that we're creating on the fly. So maybe it makes a little bit more sense. I don't know. All right, so let's just set the value here. All right, so this should now work. We need to pass it whenever we're calling the setup. So as part of the player method, this is going to complain right here. We need to go into our arguments and pass our tackle damage emitter area so that it properly compiles. So we now have access to this external dependency from all of our states. We want to hop over into the tackling state. When we enter the state, this is where we want to monitor. Monitoring equals true. And then when we exit the state, we want to make sure that we stop monitoring. Monitoring. All right, so let's go ahead and try this out. I'm going to try to go and tackle the enemy. All right, I don't know if I did it. Let's see. Ouch. Okay, it's kind of hard to see, right? Because there's no feedback whatsoever. But at least we know that there's been some collision made as part of the player that carries the ball. Okay, so now we're going to need to introduce this new hurt state so that the player can hop over into that state whenever they properly get tackled. Creating a new state should be something pretty straightforward, hopefully something that's familiar with for you, because we've done it multiple times before. We'll start by hopping over into the player scene, and let's create the animation. So the hurt animation is going to take 2 frames. So let's make this 0.2. It's not going to loop. I'm going to keep the snap to 0.1. And then starting at frame 0, let me go ahead and zoom in a little bit here. I'm going to pick on player sprite, hop over into the animation. And player sprite, I'm going to pick frame, I think it's 54. There we go. And create a keyframe. And then create another keyframe at 55. So we have 2 frames, 54 and 55 here. All right, so that's all that we need for the animation. Now we'll need to start adding the actual state. So as usual, if you remember the various steps, we start by adding a new value to our enum. So into the player script, I'm hopping over to the top, and in our state here, I'm going to create a new enum called hurt. And then let's start by creating our class. So file, new script, and here we want to position this alongside the other character states, so here, and I'm going to call this player state hurt. All right, let's give this a class name. We want to extend player state. And what do we want to do here? Well, first of all, we want to play the right animation when we go into the state. And then we don't want to stay in this state forever. So as usual, we're going to need to keep track of time. And for now, maybe we can say that we're going to stay in this state for 1 second. Let's see how this works. So duration hurt, 1 second, and let's keep track of time. Okay, and I'll set this once again when we enter the tree. And inside our process method, we shouldn't be using delta here. So I'm going to put an underscore. Let's just check how much time has elapsed. And see if that's greater than 1 second. In which case, we'll transition into the recovering state, I guess, which makes more sense. Dot emit player state dot recovering. Oh, actually, it's transition state, right? There we go. Okay, another thing I'm thinking here is that whenever the player gets hurt, it doesn't make sense for them to keep their velocity. The velocity should probably go towards 0. So, okay, so here we can probably do this here. So player's velocity equals player dot velocity dot move toward vector 2 dot 0. And I guess we're going to use delta for this one. So we'll need to know at which speed we're going to go. So let me remove this underscore here. And delta, maybe let's create a constant, maybe. So this is going to be some form of friction, right, with the air as the player is flying in the air. And so let's create another constant for this. And I don't know, maybe 30, 35. We'll see how that looks like. And the last thing we'll need to do is to give the player some height so that they kind of jump in the air as they fall down. Let's start with 3.0, I guess, or something like this. I'll create a constant again. Let's see how this looks. Okay, so we need to be able to transition into this state now that we have it. So let's hop back into the player script, and whenever we're getting hurt, get hurt here. Rather than printing out, let's go ahead and transition into this state. So switch states, player.state.hurt. All right, so let's try this. We'll try to get that first player here. Oh, well, it's a good thing we have this assert here. So we need to add this to our factory. There we go. Let's try this again. All right, there we go. And as you saw, I don't think they really jumped really high, so maybe we can tweak this. But at least they got into that state. The main thing that was a little bit weird is that they still keep the ball. They maintain the ball. So we'll need to make sure that the player drops the ball whenever they actually get tackled. So if we look at the ball script, well, before we get into that, I want to make sure that everything is pretty clear. So let me just take 1 second and make sure that things are clear for everybody. So let's hop over into the player script from the start. So we introduced a new damage emitter area that only gets monitoring whenever we are in the tackling state. Right? And then we stop monitoring as soon as we exit this state. So whenever we're monitoring, then we actually connect to the signal and we can actually call this callback method. And here we're making a quick check whether whoever we're tackling is currently part of the other team. and is carrying the ball. If that's the case, we're calling a method called getHurt on that player. And inside this getHurt method, we're having that player switch into the hurt state. Okay, so hopefully that's pretty straightforward. Anyways, let's hop now into the ball script, and we need to figure out a way to get the ball to tumble. So right now we only have a shoot method and a pass to method, which are called from the player. So we need to create maybe a third method, which is, it's actually going to look quite a bit like shoot method. So maybe we'll refactor this at some point. Let's call this tumble. We're also going to have some form of tumble velocity or shot velocity. Yeah, let's do tumble velocity, which is going to be a vector 2. All right, so here we'll set our velocity to our tumble velocity. We'll also want to free the ball from any player. And let's switch states, this time not into our shot state, but into our freeform. And lastly, we'll also want to have some height to the ball. So basically, as the ball gets tackled, it receives a little bit of height and starts bouncing a little bit. So maybe height velocity equals, let's create a constant for this. We'll call this tumble height velocity. Okay, back to the top, right here. I'm going to set this to, I don't know, it shouldn't be too high, maybe 3.0. Okay, so now that we have the ability for the ball to tumble, let's hop back into the player's hurt state. And here we know that they currently, well, they should have the ball, but just in case, let's make sure. If the ball's player equals, so if they are carrying the ball, then let's go ahead and tumble the ball. The one thing here is we need to pass in some form of velocity. And again, like this is where, you know, the logical thing here is that the ball would tumble in the same direction that the tackle was made from, because that tackle would have made contact with the ball. So we're currently passing that information over to the player's getHurt method. So let me comment this out for now. Let me just call print tumble. So inside our player script here, whenever we're getting hurt, we're getting this hurt origin data here. So we need to pass this information over to our hurt state. And I'm going to pause here for a second. I'm going to have you pause the video for a second and have you try to complete that part of the code. This is something we haven't done in a while, but it's really important. We need to pass some information to our state. So, you know, hopefully you're in familiar territory, but I would encourage you to pause the video for a couple of seconds. Try to find a way to pass that information to the hurt state so that it can be then passed over to, we can call the balls.tumble method with the right arguments. All right, so hopefully you had a chance to try this out for yourself. So basically, once again, we need to pass in information to our state. And for this, we have created an object called player state data, where we can pass in various arguments. So here, we use that for passing arguments for our shots between two states. We now need to pass in new information from where the, I don't know, the hurt direction is coming from. Maybe we can call this hurt direction. The tackle direction, not sure what makes the most sense. Maybe tackle direction? I don't know. I guess the player is getting hurt from somewhere, so I don't know. Finding names is always tricky. Okay, so then let's just following the builder pattern once again. Direction. This is going to return that exact same object. Oh, it's set her direction. Okay, so now we can hop back into the player script here. And here, rather than just transitioning into the state, we can now transition into the state while passing the proper information. Player state data.build.set hurt direction and hurt origin. Okay, so now into our player state hurt, we now have access to the hurt origin, so we can actually call the ball.tumble, and here we'll have access to this as part of the state data. Okay, and maybe we can multiply this. This is a directional vector, so let's maybe multiply this by some form of tumble speed. Ball tumble speed. Okay, let's create this constant here. I'm going to set this to 100. Okay, let's see if balls. Oh, this should be ball's carrier. All right, and then let's try this out. Okay, I'm going to let them take the ball, and I'm going to start tackling them. All right, and as you see, the ball was dropped for 1 second. Okay, so this worked well. It's a little bit hard to test right now because the AI is not able to tackle. So let's go ahead and provide the AI the ability to tackle. So back into the AI behavior, inside our AI decision maker here. Okay, we need to know here whether the ball is as part of the opposing team. So similarly to how we had a method called isBall carried by teammate, let's create another method at the bottom, just another quick helper method called isBall possessed by opposing team, opponent. That should work. All right, so first we need to make sure that someone is actually carrying the ball. And then let's just check that player's country. Okay, so back into the AI decision making here. Decisions. All right, so if the ball is carried by someone else from the opposing team, and we'll also need to check whether that person is close enough. So if our position distance to the ball's position, here I think I'm going to do something very similar to what we did for the shooting. So let's have a tackle distance, and then let's also have a random method called tackle probability. Okay, so if we're close enough and then we're going to have some form of probability here, then we'll transition into the tackling state. Okay, let me create those two constants at the top. So tackle distance, tackle probability. Let's set this to 15 pixels. And then probability, I don't know, maybe 30% as well. 0.3. All right, so if our AI is within 15 pixels of the ball is currently being carried by someone from a different team, then there's a 30% chance every 200 milliseconds that we tackle. Let's try this. Let's see if it works. Okay, so I'm going to let the opposing team take the ball. Okay, so the tackle happened. Let's see, are they going to get tackled? Yes. All right, this seems to work pretty well. I wonder if 15 pixels is good enough. I mean, you can play around with various values, but there's a little bit of wiggle room here. They don't tackle instantly. This is where the probability comes into play. But otherwise, this seems to be working pretty well. So we're reaching a good state here. Let me go ahead and persist my changes. Completed tackling ability. All right, perfect. So next up, we'll need the AI to start passing the ball. So in terms of passing, our AI is actually going to be quite straightforward. Basically, as soon as an opponent gets close enough to the player, we'll want our AI to pass the ball to a teammate before getting tackled. So for this, let me hop over into the 2D view here. We'll want some form of area to detect whether there is an opponent getting close to the player. So let's go ahead and start by creating a new area 2D. And I'm going to call this opponent detection area. And I guess we can keep it always monitoring. In terms of collision, let's make sure that we're looking for other players. And then let's create a collision shape 2D. And let's make this a capsule. Get the transform. Let's start by rotating it by 90 degrees. And then in terms of radius, let's try 40 and 120. And then in terms of transform again, I'm going to bring this forward by 20 pixels. The idea here is that the player is going to be able to detect whether opponents are coming, as he's facing this way. He won't really have a chance to see whether people are coming from behind. And then, once again, we'll want to rotate this or change the scale to -1 when they're facing the other way. So let's go ahead and start by doing this. We're going to need a reference to this inside our script. Right-click, access as unique name, hop over into the player script, and then let's go ahead and create our onReady variable. All right, and let's start by flipping it the right way. So in the flip sprites, I'm going to do exactly like what we did for our tackle damage meter area and set that to -1. Okay, so we want to use this inside our AI behavior code. So currently the AI behavior doesn't have access to this dependency, so we'll need to inject it like we usually do for the player state. So our AI behavior here as part of our setup, let's go ahead and create another variable. We'll initialize it to null, and then let's set it up when we inject it here. All right, so now player is going to complain because we're not setting it up properly. So hop over into the player script, and where is it? Right here. Let's pass our opponent detection area. Okay, so we now have access to this as part of the AI behavior. Let's go ahead and create a method to detect whether there's players from the opposing team within that area. Opponents nearby. And okay, so first let's get all of the overlapping bodies. Now remember, this can also contain teammates. So we'll want to check whether it contains people from the opposing team. For that, we can just use a find method. Player, and we'll check whether that person's country is different than our current country. Okay, and this will return an index within this array. It will return -1 if it can't find anything. So let's just check if it's returning anything greater than -1. Okay, so basically, if there is any player from another country within this area, this will return the index from 0 to anything. And then so we just want to check whether this is greater than -1. All right, so let's use this has opponents nearby method. We want to hop back into our decision making here whenever the player has the ball. So here they're trying to see if they need to shoot. If they don't need to shoot, let's check if there is opponents nearby. And let's also, before passing, let me just check if we've gone through some form of probability again. So here I'll create a constant for this. Let me hop over to the top, and right here, let's set this to 5%. Okay, so just to recap the code real quickly, basically we just created a new area that is detecting for other players. Every tick here, so every 200 milliseconds, if the player has the ball, where are we at? Here, if the player has the ball, we're going to check if there is opponents nearby, and if so, we're going to switch to the passing state. And again, within this function here, has opponents nearby, we're checking whether that area has any overlapping bodies. Remember, we're always monitoring, and we're monitoring for other players. So this can return teammates, so let's make sure that we're filtering those out and checking if there's anyone from a different team. So this should work. Let's see if the player passes the ball. All right, I'm also seeing that there's a bit of an issue whenever people get in the herd state. They actually don't go up. Okay, I haven't seen a pass yet, so let's see. Is this guy gonna pass it? There we go, perfect. Okay, so that seems to be working well. Let me fix the players getting hurt here. So I think, let's see, player hurt. So we're setting height velocity to 3 pixels per second. Let's hop over into the player. Where are we handling the gravity? Okay, we're only entering here if the height is greater than 0. So let's maybe force that to happen. So back into the player state hurt. Let's also set the player's height to 0.01. I guess 0.1 should do. All right, let's try that again. And I want to make sure that when they get hurt, they actually jump a little bit. Come on, tackle. Gosh. There we go. All right. Well, that might be a that might be a little bit high, but I guess that's fine. Oh, you can see that people can get they can get tackled multiple times. I guess that's okay. We'll polish this later on. Okay, this is working great. Let's go ahead and commit our changes. All right, and with that, we're actually already out of time for this episode. So I thought we'd actually be in a really great place, but actually looking in a little bit more details, I'm seeing that the players aren't really defending properly. So we're probably going to have to add or tweak a few of our movement steering behaviors to have a little bit more competitive gameplay here. So we'll also need to have a steering behavior for our goalie. They're kind of useless at the moment, so we'll need to fix that down the line. Still, the AI right now is just starting to look more and more polished and credible. It now has the ability to operate pretty independently, move the ball, tackle, pass it to teammates, and so forth. So I think we've actually made some really good progress today. We wrote quite a bit of code, so if you have any questions regarding any line that you wrote today, please don't hesitate to ask in the comment section below. I really want you to fully understand everything that we write. And so we're now about 8 hours into this tutorial series. I can't really believe it. Huge thank you for watching this series and getting so far. If you do like this content, if you want to see more tutorials like this, please go ahead and hit the like and subscribe buttons to help the channel grow. Time to take a quick break, and I'll see you in the next episode. Cheers.